All right, so in this video, we're going to continue our look at arrays. So in part one of our video on arrays, we introduced this concept of an array, and we saw how arrays could be used to keep track of related data, where we knew in advance how many things we had to keep track of. So that was a very important concept. And another thing I wanted to note is that with arrays, there are a type of data structure. So a data structure just basically defines how we represent data within a computer so that we can retrieve and store data efficiently. And there's lots of different data structures out there. One of the data structures I've covered previously is on vectors. And the main difference between a vector and an array is that a vector is able to grow and shrink dynamically, whereas an array is not able to do that. But they're very similar beyond that. In general, you would probably want to use a vector in most cases as opposed to using an array if you had a choice. But I think it's a good idea to know about arrays because it's a very classic data structure, and sometimes they are useful, and they really are the backing data structure for a lot of other data structures that we'll look at in later videos. So before I get into really the new material for today, I wanted to go back and do a quick review on arrays and just look at the structure of everything. So we said that array was, we had this contiguous series of elements that would have to be of the same type. So here we may have a 5-element double array. So we have 5 elements being represented here, and each individual element has a double value in it. So the values are being represented there in red. And the name of this particular array is maybe array A. So that would be you would have to specify that whenever you created the array. And we have for each element an associated index, and we start our index count at 0. And the very last index would always be one less than the size or length of our array. So the size or length of this array is 5, and we have this index value of 4 being the last valid index. So those were our indices, and we could go about accessing any particular element of our array by simply specifying the name of the array and then specifying open square bracket, index, close square bracket. So this open square bracket, close square bracket is an actual operator associated with arrays for us to access a particular element in that array. So if this was to be used somewhere in code, it would allow us to access the 4th element of our array, the one that has the index value of 3, which has this value of 8.7. The other thing that we really talked about in the last video on arrays was this idea of being able to traverse an array by using a for loop. So the new stuff for this particular video is going to be related to the array container class. And the array container class is part of the new C++ standard, more specifically the standard library. So last year in 2011, I'm recording this in 2012, so last year they approved a new set of standards associated with the core language and also the standard library associated with C++, and this array container class is part of that. So what we're going to do is go out to the web and just do a search for C++ documentation and learn a little bit more about this C++ array container class and what it's all about. So in general, a container class is just a class that allows us to hold data of any type and perform certain operations. So depending on what sort of structure it is, what sort of container class it is, we'll have various types of operations. So later on, when I make other videos on data structures, I'll probably discuss other container classes and their respective advantages and disadvantages. So let's go out to the web and just do a search for C++11 documentation and read a little bit about the array container class. All right, so I'm over here on Google search engine, and I'm just going to do a search for C++11 documentation. And I've previously done this search before. And the second reference is the one that we want to go to, at least the one that is the CPP reference.com. And this is a really good reference that contains the latest and greatest information associated with the C++11 standard. So if you go under Containers Library, you should see Array there, and that's what we want to look at today. That's the Array Container class. So it tells you a little bit about the Array Container class in general, and then it lists out all the member functions associated with this class. So there's a lot of different member functions. We have this add member function, which allows us to access a specific element in our array. This gives us the same sort of functionality really as the open square bracket, close square bracket that we used before to access a specific element, but now it has what's called bounds checking. So this open square bracket, close square bracket doesn't do bounds checking. And what that means is the at function is actually taking a look to ensure that the element that we're accessing, or the memory location that we're trying to access, is associated with our array. So say that we had a 5-element array. So the valid index values for a 5-element array would be 0, 1, 2, 3, and 4. So if we were to specify the name of the array, open square bracket, close square bracket, so making use of this operator here, and specify, a value like 5 within that open square bracket, close square bracket, we'd be trying to access an element that's not associated with our array, or access a memory location that's not associated with our array. And that could have a very bad consequences depending on what's actually located at that memory location. So with the at, what's going to happen is if we try to access a particular location in memory that's not associated with our array, it's going to throw in an exception, or it's going to have an error occur whenever we do that operation. And maybe we'll take a look at that whenever we get over into Eclipse. So a few other member functions, they have a function to be able to access the very first element with front, the very last element with back. They have these iterators here that allows us to traverse over an array. So as opposed to setting up a traditional for loop with a for loop counter or a loop counter, we can just use these iterators instead. And there's certain benefits to making use of these iterators. Capacity, so we can use a function to test whether the array is empty, get the size of the array. So this is a huge thing to be able to know the size of the array just by calling a function as opposed to just keeping track of it in some variable. Max size, so we can actually get the maximum size for a particular array on a particular system. So depending on what architecture, what compiler you're using, there may be different max sizes depending on that system, and you can get that using max size. So there's a lot of functionality provided here in this array container class that we can make use of, and it provides a huge benefit over the traditional C++ standard array implementation. So let's go over to Eclipse now and make use of this array container class. Okay, so I'm over here in Eclipse now, and I've opened up our project and also the file that we were using in the previous video whenever we introduced arrays. And what we want to do now is modify this particular file to make use of the arrays container class. But in order to do that, we've got to make a couple of changes within Eclipse to basically notify the compiler that we're going to be making use of the new C++ 11, or at least some of the features from C++ 11. So in order to do that, we're going to apply those settings just to this particular project. So if you go over here to your project, whatever it's named, in my case it's named Arrays, you can right click on it and then go down to Properties and click on that. And then you'll have a listing of menu items here, and you want to expand this C++ build. So go ahead and expand that by left clicking on the triangle or the plus, however it shows up, maybe some other symbol. And then go to Settings. And under Settings, go under Tool Settings, GCC C++ Compiler, and then select Miscellaneous. And over here under Other Flags, we'll want to type in a new flag, which we'll just put at the end, and we'll do a dash, std, and then equals, and then put in C++ 0x. So before C++ was, or C++ 11 was known as C++ 11, it was C++ 0x because they didn't know what year it was going to be released, and they just had the X there as kind of a placeholder. So that's the reason why that flag looks maybe a little bit funny. So once you have that, you can go over here to C++ General and expand that listing, and then go to Paths and Symbols, select that, and then go to Symbols here, the Symbols tab, and then select GNU C++, so make sure GNU C++ is selected, and we're going to add in a new symbol here, and that symbol looks like this, so it's all in caps, so go ahead and maybe put the caps lock on, and then we'll have underscore underscore, and then it's going to be GXX underscore experimental, and then underscore CXX 0x underscore underscore. So at the time for this particular compiler, these flags and symbols were all experimental at the time. I'm assuming these will be updated at some point in time where you won't have to have all this experimental, and even setting these flags won't even be required. It'll just be built in. So go ahead and click on OK and click Apply, and you'll get a little dialog box here to update the index. You can go ahead and click Yes for that, and then click on OK. And now we should be set up where we can make use of the arrays container class. Okay, so the first thing we need to do is just do a pound include for the array container class. So that's just pound include space angle bracket array, and then we have the close angle bracket. So now we can make use of the array container class. So in order to create an array using the array container class, it's very different syntax, but it's very similar to what we did with the vector. So the vector is also a container class. It's just allowing us to support a dynamic number of elements, meaning that we can change the number of elements throughout the execution of a program, whereas with an array, once we create it, it's fixed. So the way we go about doing that is just type in the word array, and then space, and then angle bracket, and then we'll specify the type, which in this case is going to be a double, and then we'll do comma, space, and then specify the size, which if we wanted to follow what we did previously, we'll say the size is 5, and then close angle bracket, and then space, and then the name. So I'll just name it the same thing, rainfall. Now, I'm going to get rid of this line here where we previously declared an array using the traditional C++ style. So that's not using the array container class, but you can kind of see the difference between these two in terms of the syntax. So let me go ahead and get rid of this particular line of code, save this, and compile it just to see what's happening so far. So if we compile this, we can see that our code compiles cleanly so far, so everything appears to be working, and you can also see that our flag is in here and also the symbol that we specified previously, so you can see those showing up whenever we compile our code. So let's make use of some of the member functions that we saw in the documentation. One of the member functions we saw was the size function, which is really cool to be able to access the size of an array at any point in time, or the array knowing its size. So the way we go about doing that is here where we have the for loop, we made use of the size previously just by hard coding it in there, just typing out, the size was 5, let's just type that in there. But that's not really a good way to code things because it doesn't allow our code to be generic. Now we're using the array container class. We can just specify the name of our array. So this is referring to a particular array, and then use the dot operator and then specify size, and then open paren, close paren. And that gets us the size of this particular array. So if we were to change up our array and make it of size 10, 20, 30, doesn't matter. It's getting the size of that particular array called rainfall. So I'm going to just copy that particular piece of code and replace every instance where I had the number 5 in our other two for loops with that bit of code where we call that function. So let me go ahead and save that, and I'm going to just build it again just to see that it builds okay. And you do see that we get a warning here, and that warning is occurring because this size function actually returns a value that's of type size t, and we're trying to compare it to an int. So this is a signed value, and this is an unsigned value, and that's the reason why we're getting this warning down here where it says we're trying to do a comparison between a signed and unsigned value. So if you wanted to get rid of this particular warning or these warnings down here, you could do one of two things. You could change this int here to be of type size t, or you could cast what's being returned here from size to be an int. So let me just do the size t option. So do size underscore t instead of int there for the declaration of the loop counter I, and then I'm going to save that, and we should get rid of one of those warnings whenever I build this. So yeah, the first warning has now disappeared because these are now the same type. So if you want to change that for the other two, you can. Let me cover one other operation here, and what I wanted to show you is, well, let me first just talk about this idea of bounds checking. We had mentioned this before. So whenever we do something like this, so say we did rainfall, open square bracket, 5, and then assign the value of 7.2. Well, we can compile this and we can run this, and what will happen, I don't know what will happen whenever we run this. It may be perfectly fine. It just really depends. What we do know is that this particular index 5 here is not associated with the array that we allocated. So whenever we allocated this array, we only allocated space for 5 doubles, so that all 5 of those doubles, the space for them was allocated contiguously. So this is the next space up. It's probably like 64 bits beyond this particular element here. This is the next 64 bits, the next 4 bytes. And if we write a value into that location, it may be perfectly okay. There may not be a problem whenever I run this, but it's certainly writing over something that's at that memory location. And it may not be of an importance in this particular execution, but it could be in some other code execution. The bottom line is we don't have any sort of bounds checking whenever we make use of this operator that accesses a particular element by doing the open square bracket, index value, close square bracket. So let me go ahead and save this bit of code and then build it. And then if we run this again, so let me go ahead and run this. I guess we haven't run it before, so it still runs the same, and we can go back. So it's already executed this particular for loop, and now it's on this for loop asking us to enter in rainfall amounts. So we could enter in 2.5, 4.2, 1.7, 0.5, 0.9, and then we'll get those printed out from the third for loop that we have here. So it looked like everything was okay, but that's really not a good thing for us to write into memory areas where we really shouldn't be writing into. And with the traditional array, using the open square bracket, closed square bracket, which is still supported by the array container class, it doesn't do any bounds checking. But we could do this. We could, if we wanted to be a little bit safer about things, do rainfall and then do the dot operator and then make use of the at function and then specify a particular index like 5. And this time we're going to assign a value. In this case, we're going to assign the value of, what did we have before? I don't remember, 7.2, something like that. So we can assign the same value. And this time we'll actually get a runtime error. It's going to throw an exception. And you may think that this is worse, but it's actually better, because whenever we're testing things out, we can see that, oh, we've actually tried to write into a memory area where we shouldn't be writing. So let me go ahead and compile this again and run it, and we'll see what happens. So yeah, it says the arrays exe has stopped working, so let me cancel that. And you can see down here in the console, it says that terminate was called, throwing an instance of out of range. So it was indicating that whenever we invoke this at function associated with a particular array, that it threw this out of range exception. So that's a good thing for us to have that, and certainly we could write code there to catch that particular exception and try to handle it in a more elegant way as opposed to just crashing our program. But this may seem worse, but it's actually better. So that's pretty much what I wanted to cover in this particular video. I may come back and talk more about some of the other member functions with the array container class, but that's it for this video.